Good morning friends. Today we are going to see the next point from this topic, that is the damped oscillation. At the same time we are going to see the point regarding the free oscillation, forced oscillation and the resonance. Friends, when we are saying about the damped oscillation, so first we should know what is the definition of the damped oscillation. The oscillation in which the amplitude of the particle goes on decreasing with respect to time, then that kind of oscillation is known as a damped oscillation. For example, suppose if we have a simple pendulum and if it is released upon the mean position, then it will start vibrating as the time increases. But later on, it is found that due to the air resistance, its amplitude will be goes on decreasing, and finally it comes to the rest position. So if you are plotting the graph, then you can observe that the amplitude is maximum, then slowly it will be goes on decreasing with respect to the time, and finally it will becomes a zero. So such kind of oscillation is known as a damped oscillation. And remember, if the amplitude is not decreasing, if it is constant, then that is called as a undamped oscillation. So in the pendulum watch, you can observe that with the help of the cell, when the external energy is applied, so that the amplitude will remain constant, and if the amplitude is constant, then that is called as a undamped oscillation. So based on that, you can conclude that there are two types of the oscillations, damped and undamped. So the damped oscillation, amplitude will be goes on decreasing, while in undamped oscillation the amplitude will remain constant. That is a very important thing which we should always remember. Friends, here we are going to see one equation in which one spring is here, a wooden block is here, and the other end of the wooden block is attached to the vane, and it is dipped in the water. So this is arrangement here. So one spring is there, spring is attached to the block, and that block is attached to the vane, and it is dipped in the water. When the oscillations are given, in the spring will provide the restoring force, and the block will be set into the oscillation, and at the same time the vane will be also set into the oscillation, and the mechanical energy will be get transferred. But due to the opposition in the by the water, the amplitude will be goes on decreasing, and it will become zero. So that kind of experimental arrangement is here. Friends, the net force acting will be Fd plus Fs. What is Fd? Fd is a restoring force created by the block. Fs is a restoring force which is acting by the spring. So here Fd is equal to minus B into V, where B is a constant, V is a velocity, and Fs is equal to minus K into X, where K is a force constant and X is the displacement. Now if we add this, we are getting F is equal to minus BV minus Kx. When the minus will be here, according to the Newton's second law, what is the value of force? F is equal to ma. Force is equal to mass into the acceleration. So we can write here ma is equal to minus bv minus kx. Now take on the RHS side, from RHS to the LHS, it will become plus. So ma plus bv plus kx is equal to 0. Now what is the a? A is the acceleration. What is the meaning of the acceleration? It is the second derivative of the displacement. So we can write m as it is d2x upon dt square plus b as a constant. What is the velocity? The rate of change of displacement. So v is equal to dx by dt plus kx is equal to 0. So this is nothing but one kind of a differential equation. Again I am going to explain this part. F is equal to fd plus fs. Fd is equal to minus bv. Fs is equal to minus kx. Now f is equal to ma, so we are getting the equation ma plus bb plus kx is equal to 0. Then what is the a? A is the acceleration. What is the value of acceleration? Acceleration is nothing but the second derivative of the displacement. So we can write m d2x upon dt square plus b dx by dt plus kx is equal to 0. Now if we solve the differential equation, then the solution in your textbook it is given directly, so you should also remember the solution as directly. The solution of this differential equation is x is equal to a e raised to minus bt upon 2m cos of omega dash t plus phi. So this is the solution of this differential equation of, or we can say this is the solution of the damped oscillation. Friends, here if we observe this term a e raised to minus bt upon 2m upon bt upon 2m, so x is equal to k sin omega t or x is equal to a cos omega t, that is the equation for the displacement. So this quantity is nothing but the amplitude, and this amplitude has a negative exponential power. So this will indicate that a e raised to minus bt upon 2m is the amplitude of damped oscillation. As it has a negative term, so the amplitude will be goes on decreasing. That is a mathematical answer why the amplitude goes on decreasing. Again friends, if we write the angular velocity based on this equation, then its formula is omega dash is equal to under root k upon m minus b upon 2m bracket square. This is the formula for the angular velocity. If we want to find the equation for the period is equal to t is equal to 2 pi upon omega dash. So 2 pi upon substitute the value under root k upon m minus b upon 2m bracket square. Friends, remember in your textbook the direct thing solution is given, so you should also remember the formula directly. So this is the equation regarding with the damped oscillation. Friends, remember when you are writing the equation, first you should draw the diagram, and then here remember the force is divided as Fs, Fd and F is equal to ma. Based on that, first create the differential equation m d2x upon dt square plus b dx by dt plus kx is equal to 0. After this, you should write the solution of the differential equation is x is equal to a e raised to minus beta upon 2m cos of omega dash t plus phi will be here, but here I think there should be the plus and minus phi should be required because the amplitude may be the positive and it may be the negative. So this is the solution of the differential equation. After that, we have to write that omega dash is equal to under root k upon m minus b upon 2m bracket square, and in order to find the equation for the period, you have to write t is equal to 2 pi upon omega dash. So t is equal to 2 pi under root k upon m minus b upon 2m bracket square. So this is the total equation regarding with the damped oscillation. Friends, after this in this topic there is a point regarding with the free oscillation, forced oscillation and the resonance, and this is a total theoretical part. So just I am going to explain here, there is a no equation part, just I am going to explain this part. So you have to make the notes as per the you can make the notes as in your own words. Once you understood what is free oscillation, forced oscillation and the resonance, then it will be very easier. In your textbook, based on this diagram, they have explained such kind of terms. Okay, now let's see one by one regarding with the free oscillation. Basically, if we have a simple pendulum and if we release it, and if when it is vibrating, then its frequency is known as the natural frequency, and the vibrations are known as the free oscillation. As the pendulum is oscillating with the natural frequency, we can say it has a free oscillation. Suppose again we have to take a simple pendulum, and if its amplitude is decreasing, we are applying external force, then that kind of oscillation is called as the forced oscillation. And if we are applying the force and if the particle is vibrating with the natural frequency, both will matches, then the resonance will be created. For the resonance, natural frequency and the frequency of the external force should be equal. That is the condition. Okay, now here you can observe that here A, B, C, D, these are the four pendulums we have taken here. First, we are going to write regarding the free oscillation. So the pendulum A, when it will be strike, when it is given oscillation, then it vibrates with the natural frequency. So such kind of oscillation is known as the free oscillation. And we know the equation for the period of simple pendulum, that is T is equal to 2 pi under L upon G. And if we are writing in terms of the frequency, then we can get frequency is equal to N is equal to 1 upon 2 pi under root G upon L. So this is the natural frequency with which the body A is vibrating. So this is about the free oscillation. Now, if it is attached to the different pendulums B, C, D, here you can observe that the lengths are different. The length of pendulum B is less than that of the A. The length of pendulum C is equals to as that of the A. The length of the D is greater than that of the A. Now force is applied to the pendulum A. Now we are going to see the terms forceful oscillation. When the force is applied to the pendulum A and released, then it is observed that the force will be applied to the pendulum B from B to C and C to D. Means all the four pendulums will be in the oscillating state. It is observed that as the driven force will be applied on the B, C, D and they will be set into the motion, then it is known as a forced oscillation. Means the oscillation in which the body vibrates by the application of external force, then such kind of oscillation is known as a forced oscillation. Now let's see about the third condition, that is the resonance. Here it is observed that when the force is applied by the pendulum A, then the amplitude of B, C and D are observed, and the conclusion was that the amplitude of pendulum B is greater than that of the A. The amplitude of pendulum A and C are the greater, and the amplitude of D will be the less. So that was the conclusion regarding the amplitude. And again it is observed that the amplitude of A and amplitude of C are the same. It means the frequency of applied force and the vibrating body both are the same. At that time resonance condition is created. In the resonance condition, the particle vibrate with the maximum amplitude. So we can draw the conclusion that the amplitude of the particle C is greater compared to the B as well as the D. So here what we can, if we are going to plot the graph, then it is observed that the amplitude is maximum at a specific frequency. That frequency is known as the resonance frequency, and then the amplitude will goes on decreasing. So at the resonance, the particle will vibrate with the maximum amplitude. So that was the condition here. So friends, I hope you have understood the concept of free oscillation, forced oscillation and the resonance. In one words, if you want to write, then we can write that the body which vibrates with the natural frequency is known as a free oscillation. Forced oscillation, the body which vibrates by the application of the external force is known as forced oscillation. And the resonance, the body in which the body in which the frequency of vibrating body is equals to the frequency of the external force, then the resonance condition is created. In the resonance, the amplitude of the particle is a maximum. Friends, in pendulum A, B, C, D, we can say that the length of pendulum A and C are the same, so that the frequency of A will matches with the C, and at the pendulum C, the resonance condition is created. Here, the energy absorbed by the pendulum C is greater compared to the pendulum B and pendulum D. So that was a conclusion here. Friends, in this way we have completed the important topic oscillation. I hope you have understood today's part. Try to make the proper notes. Thank you. Have a nice day.